Okay, so in this video I will be speaking about the joint probability. Okay, let's write it down. Joint probability. Okay, so let's first look at it. What's the joint probability? So probability, when we say the joint probability, let's say in the example of the event A and event B happening, so we can say the probability of both event A and the B happening together simultaneously at the same time, because here the key point to retain is that both event A and B should happen at the same time. And how do we write it down? So we write it down as a P, A, and B, which is equal to the P, A intersect with the B. So you remember from our earlier videos, when we said A or B, which is also kind of a union probability, we write it down A union B. Here we use the addition rule, okay? We use the addition rule. Do you remember the addition rule? How did we calculate it? So this equal to the probability of event A happening, plus we have probability of event B happening. Then we have to deduct minus A intersect with the B, okay? And we said if our event A and event B are mutually exclusive event, ME, then this becomes our zero, okay? Then what we have only it remains the probability of event A or probability of event B happening. So rate of the joint probability. Okay, so now when we say A and B, so this is actually equal to the A intersecting with the B, meaning that this time we have to use a multiplication rule, okay? Multiplication rule. Since we use the multiplication rule, meaning that instead of addition, when we use with the OR statement, whenever you see and, you have to multiply it. So meaning that when we have P, A, and B, we're gonna, okay, write it down again, A intersect with the B, then we're gonna say it's gonna be probability of event A happening, considering that the B is already happened, event B is already happened, multiply with the probability of event B. So how do you read this out again? So you say that event A will occur given that the B is already happened, okay? Also, we can say that this is also the same as the probability of event B happening, considering the A is already happened, multiplied with the probability of event A. So this gives us the same result. So let's say if you have two independent events, okay, let's say independent events, okay. So how does it look like for the independent events? So independent events, so events that do not depend from each other, so they are happening independently. So then, in that case, the probability of event A happening considering the B is already happened is equal to the probability of event A. Why? Because A doesn't depend on the event B. With the same logic, likewise, we can say that the probability of event B happening considering the event A is already occurred, so is equal to the probability of event B. Why? Because the B doesn't depend on the event A, so these are two independent events. Then, in that case, what's going to be our joint probability for the independent events? So let's say then A and B, okay, probability of A and B, it's gonna be, again, if we take the same logic, let's say, which we say probability of event A happening considering B is already happened, multiplied with the probability of event B. So here we are going to replace that part with that. So meaning that then we will obtain a formula of probability of event A multiplied with the probability of event B. Again, or, and with another words, we can say that it's also equal to the probability of event B multiplied with the probability of event A. So now you understand how does it this formula works for the independent events, okay? I want to show you as well another point. It's interesting because most of the time you will see writing of the probability of event A and B. Then we have another writing, let's say, such as probability of AB. Then we have probability of BA. So the thing is that how this three is different from each other. They are different because in the first case, this is equal, okay, A intersect with a B. So this is happening when event A and B happening at the same time, simultaneously. But here, what we see is that here, when we write A and the B, so it means in probability the event A happening first, okay? This is happening first. Then you have a second event, your event B happening, okay? Second event happening. And here is the same. When you write a probability of B and A, so it means your event B happening first, then you have event A happening, okay? So it means that the order plays an important role in the sequence of the event. So from that logic, we can say that then the probability of event A and B is not equal to the probability of event B and A. Okay, this is important to keep in mind and also to understand why it's not equal. And also we can say the probability of event A and B is not always equal to the probability of event A and B. So you have to always carefully read the context of your problem, what's requested and how's it given. Then we have